Speaker is Dr. Yongxin from Hong Kong Polytechnic University, and she had another look on thermal comfort, and particularly its dynamic effects as someone is following a certain path and their thermal exposure has some amount of accumulated impact.
Okay, thank you for your introduction. Hello everyone, I'm Yongxin from Hong Kong Polytechnic University, and the topic I'm going to share with you today is dynamic thermal comfort for pedestrian who's walking in road. So we are looking in the factor of short-term thermal history. So just a little bit background before we started. The cities and many countries worldwide are going through the carbon emission reduction process. So the public transport is one of the important methods that the government will choose to reduce their carbon emission. So if the citizens choose public transport for their daily commute, there is a recent research data that says that, for example, the citizens from Shanghai, there will be a walking distance of about 1 kilometer for their daily commute every day. So if the citizens are trying to use public transport for their daily commute, they have to walk a little bit or cycle a little bit. So the thermal environment, of course, will affect their willingness whether they want to take the public transport for their daily commute. So if you are walking on the road, one might experience many circumstances. For example, inclement wind environment, or one might encounter discontinuous experience of tree shading or sun exposure, and maybe they will also walk through the long distance of shading provided by buildings. So how does this dynamic wind and solar conditions in walking spaces affect one's thermal evaluation? So to answer this question, we did a little research in Beijing, China, and during our experiment, we asked the human subjects to walk in the outdoor area for about 1 kilometer. And so here's the walking road they have in their experiment. So for the spring was conducted in both spring and summer. And for both spring and summer, the human subjects walk clockwise, following from point 1 to point 9. And for the summer experiment, we also have we also asked the human subjects to walk anti-clockwise, so starting from point 9 to point 1. So when they are working, we use a mobile weather station to measure their thermal environment. So when human subjects were walking, we have 9 points for them to stop and survey to let them express their thermal response of their current situation. So here are the photos of the 9 survey sites. So as I mentioned, they will walk clockwise and anti-clockwise. So these 9 types of environment, we covered 3 different kinds of conditions, including direct sun, tree shading, and building shading. And I want to draw your attention at point 4, point 7, and point 8 here. Point 4 and point 8, they have similar thermal condition where the human subject will be exposed to the direct sunlight. And for the point 7, the building here forms a natural wind channel effect that the wind there will be relatively stronger than other points. So along this walking road, because of the arrangement of the building and trees, so naturally it forms a hotter, it forms a different kind of thermal environment. From point Y to point 5, there's a hotter thermal environment than point 5 to point 9. Okay, here's just some result of the variation of the thermal environment along the walking path. First, let's focus on air temperature and wind speed. Well, if you notice the legend show at the bottoms here, the variation of air temperature actually was really limited. It's within 1 degree. And for the wind speed, the wind speed more or less are similar, and except for the point 0.7. The point 0.7 because the buildings there, the wind is relatively stronger than the other points, but for the other point, it actually also stays, how's it? Within 1.5 meter per second. And however, the shortwave radiation recorded along the road has a very large variation, starting from 25 to 615 watt per square meter. And the SET we calculated along the road actually follows the fluctuation of the shortwave radiation here. And it has the fluctuation range between 20 to 15 degrees Celsius. Okay, now let's come to the result of the thermal sensation distribution. We had a comparison of the thermal sensation difference for different for different seasons. And we noticed that the thermal sensation difference was only show obvious difference at several points. For example, the starting of the road, the ending point of the road, and also point 4 and point 8 here, which is the points that human subjects will be exposed to the direct sunlight. And for the other point, the human subject does not have any thermal sensation difference for 2 seasons. And now let's focus on the influence of the thermal parameters on thermal response. Well, we use the Spearman analysis to compare the influence of three thermal parameters on thermal response, which is air temperature, main radiant temperature, and the wind speed. And the thermal response we consider was thermal sensation, thermal comfort, and thermal acceptability. And if you focus on these three figures, you will find that the air temperature always dominant the thermal response, no matter sensation, comfort, or thermal acceptability. And the solar radiation, which is the main radiant temperature, only has a bit higher correlation factor than air temperature under the direction sunlight location, which is zero point 0.4 and zero point 0.8. And for the wind speed, it only dominates the thermal sensation at 0.7, where it is much higher than the other survey points. And now we come to the influence of short-term thermal history to the right here, right now thermal evaluation. So we calculated the past SET starting from their survey point. We calculated the SET from the past 5 seconds to the past 19 5 seconds, and to do correlation with the past SET and their current thermal response. And if the coefficient, the absolute value of the coefficient is closer to 1, it says that they have higher correlation with their current thermal response. So let's focus on the figures here. And we notice for no matter the clockwise experience from spring, clockwise and anti-clockwise experience from summer, we notice that the correlation coefficients first fluctuate more or less the same. They maintain more or less the same at the beginning, and then they start to decrease after several seconds. And for the clockwise experiment conducted in spring, the correlation between the past thermal history and the thermal sensation actually starts to decrease from the past 20 seconds, and its correlation with the comfort and acceptability starts to decrease from the 20 seconds as well. And for the thermal experiment, both the the thermal sensation with the past history also starts to decrease from the 20 seconds. And however, for the anti-clockwise experiment, the correlation starts to decrease from the past 35 seconds. So we noticed that we noticed this value are quite similar to each other, 20 to 35 seconds. And now let's come to the influence of thermal exposure sequence to thermal response. Well, I would like to draw your attention at point 4 and point 8 here because their thermal condition was similar to each other. And for the human subject, they arriving point 4 at clockwise and arriving point 8 at anti-clockwise sequence as the walking distance are similar. So, but however, anti-clockwise and arriving point 8 in anti-clockwise and arriving point 4 in anti-clockwise and arriving point 8 in clockwise sequence, they have different thermal history. So arriving point 4 in anti-clockwise, their experience is hot followed by cool thermal experience. However, arriving point 8 in anti-clockwise, the thermal experience was cool followed by hot experience. So we noticed that arriving point 8 in anti-clockwise sequence, the human subject has higher thermal sensation than arriving point 8 in clockwise sequence, and their thermal comfort and thermal acceptability is also lower. We also compare the distribution of thermal sensation and acceptable thermal sensation for these two conditions. And we noticed that arriving point 8 in anti-clockwise experiment has no obvious peak value of TSV distribution. However, its 25% and 75% TSV was higher than that arriving point 8 in clockwise experiment. And for the acceptable thermal sensation, arriving point 4 in anti-clockwise experiment, they does not have any acceptable thermal sensation volt. However, an arriving point 8 in clockwise experience, they have we have some record of the acceptable thermal sensation. So so we can find that the thermal exposure sequence actually has influence on people's evaluation of their road, and hot followed by cool thermal experience is better than cool followed by hot experience. So here are the conclusions and insights we have from this study. So we have discussed the influence of dynamic thermal comfort in working space. And from our experiment, we found that the shortened thermal history actually have influence on pedestrian thermal evaluation. And the TSV is mainly affected by the past 20 to 35 second thermal history, while thermal comfort and thermal acceptability are mainly affected by the past 35 thermal history. And also the sequence of thermal exposure also have obvious influence on pedestrian thermal evaluation, and hot followed by cool thermal sensation, thermal experience can help to improve the pedestrians' evaluation to their walking path. And we hope this finding can provide some insight for urban planners when they designing the urban walking spaces. If you have further if you want to find more information about our research, you can go to this publication here. Thank you. Do I have some time? Yeah. I want to spare one more minute to have a little bit advertisement here. Here's a new Borong journal, which is Architectural Intelligence. This journal is launched in May 2022, and it's a peer-reviewed journal. And our research focus is smart habitat, virtual habitat, and space habitats. And we would like research to be published in civil engineering, environmental engineering, computer science, and social science. So if you have any interesting research they're going to publish in the near future, please consider our journal. Thank you.
Questions?